In this lecture, we are going to see how to diagonalize a matrix. For that, first we need to find the eigenvalues and eigenvectors of the matrix. Then we have to normalize the eigenvectors. Then write the normalized model matrix. And then we have to use the orthogonal transformation to find the diagonal matrix. First, write the characteristic equation. The characteristic equation is determinant of A minus lambda I equal to 0, which implies lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is the sum of the main diagonal elements, sum these three elements. This is the main diagonal elements, sum these three, 6 plus 3 plus 3, so which is equal to 12. And s2 equal to sum of minors of main diagonal elements. First find the minor of this element 6. So for that, remove this column and row, find the remaining determinant 3 minus 1 minus 1 3, plus next find the minor of this element. For that, remove this column and row and find the remaining determinant 6 2 2 3. Similarly, find the minor of this element, remove this row and column, then find the remaining determinant 6 minus 2 minus 2 3. Now find this 2 by 2 determinants. So 9 minus 1 plus 18 minus 4 plus 18 minus 4. So which is equal to 8 plus 14 plus 14. So 28 36. Similarly, find S3. S3 is nothing but the determinant of the matrix. Determinant we can find by expanding any rows or any columns. I'm going to expand through the first rows. So for that, 6 into, now find the minor of 6. So that is 3 3s are 9 and minus 1 into minus 1 1. So 9 minus 1 minus minus 2. Next element is minus 2. This minus 2, and remove the corresponding row and column. Then find the remaining determinant. So 9 minus 1, and then plus next element is 2. 2 into this 2, and remove the corresponding row and column. Find the remaining determinant. So 2 minus 6. Now if you simplify, then you get the determinant value, that is s3 value. So s3 equal to 32. So the characteristic equation is lambda cube minus s1 lambda, s1 is 12, minus 12 lambda square plus s2 lambda, lambda 2 s2 is 36 lambda minus s3 is 32 equal to 0. If you solve this equation, then you get the roots as lambda equal to 8 2 2. So these are the eigenvalues of A. Next we need to find the eigenvectors. Let x equal to x1 x2 x3 be the eigenvector corresponding to lambda, the eigenvalue. So therefore, determinant of, not determinant of, a minus lambda I into x equal to 0. Now substitute a, the given matrix, and lambda is the eigenvalue, and I is the identity matrix, and X is the column matrix x1, x2, x3. Now if you substitute, then we get this system of equation. Let the system is 1. Now substitute lambda value 1 by 1. Then 1 becomes, so case 1, lambda equal to 8. Then 1 becomes, if you substitute lambda equal to 8 here, then what do you get? Minus 2x1 minus 2x2 plus 2x3 equal to 0. So which implies if you multiply by divide by minus 2, then what do you get? X1 plus x2 minus x3 equal to 0. Similarly, the second equation, this equation, minus 2x1, substitute lambda equal to 8 here, then 3 minus 8 minus 5 x2 minus x3 equal to 0. And finally 2x1 minus x2 plus 3 minus 8, so minus 5 x3 equal to 0. Now we have three different equations. You consider any two equations, then find the values of x1, x2, x3. That should be a non-zero vector. The eigenvalue is 8. Now we have to find the corresponding eigenvector. That vector should be a non-zero vector. Now consider first two equations, x1, x2, x1 plus x2 minus x3 equal to 0, and 2x1 plus 5x2 plus x3 equal to 0. If you want, you can divide by minus, then you get this one. Now use the cross ratio method to find the values of x1, x2, x3. To find the value of x1, you remove the x1 column, then find the remaining determinant of the coefficients. So 1 minus 5. So 1 plus 5, which is equal to minus x2 by, always put minus in front of x2, then remove the x2 column, then find the remaining determinant of the coefficients. So 1 minus 2, 1 minus 2, which is equal to x3 divided by, now remove the x3 column, then you find the remaining determinant of their coefficients. So 5 minus 2. So which implies x1 by 6 equal to x2 by minus 3, which is equal to x3 by 3. So if you multiply by 3, then what you may get? Capital X1 equal to 2 minus 1, 1. So this is the one of the eigenvector. Similarly, you find the next two eigenvectors. So case 2, lambda equal to 2. Then the system 1 becomes so this one. Now in this substitute lambda equal to 2, then what you may get? So 4x1 minus x2 2x2 plus 2x3 equal to 0. Similarly, minus 2x1, if you put lambda equal to 2, then plus x2 plus minus x3 equal to 0. Then 2x1 minus x2 plus 3 minus 2, 1. So x3 equal to 0. Here, second and third equations are same. So first consider first two equations. Here also first two, if you divide by 2 in the first equation, then you have to make it 2x1 minus x2 plus x3 equal to 0. So all three equations are same. So if all three equations are same, then substitute arbitrary value for any two variables, we have only one equation, that is 2x1 minus x2 plus x3 equal to 0. Let x1 equal to 1 and x2 equal to 0. Then what is the value for x3? x3 equal to minus 2. Therefore, capital X2 equal to 1, 0, minus 2 is the next eigenvector. And to find the third eigenvalue, here the matrix is symmetric matrix and the eigenvalues are repeated. So in that case, to find the third eigenvector, use the orthogonal property. We know that x2 is perpendicular to x3, which implies x2 transpose x3 equal to 0. Before that, let x3 is ABC. Now find this ABC value using this property. You know x2 is what? 1, 0, minus 2 as a column matrix. x2 transpose is a row matrix. 1, 0, minus 2 into x3 is ABC, which is equal to 0 matrix. So what you may get? A plus 0B minus 2C equal to 0. And also x3 should satisfy x3 should satisfies this equation, because we are finding the eigenvector for lambda equal to 2 only. So that means it should satisfy this equation. X3 should satisfy this equation. Am I right? No, 2x1 minus x2 plus x3. So if you substitute ABC for x1, x2, x3, then what do we get? 2a1 minus, not 2a1, 2a minus b plus c equal to 0. Now consider these equations and solve, then we get the values of ABC. Solve 1 and 2 using the same cross ratio method. So to find the value of A, remove the first column, then find the remaining determinant. So then what do we get? 0 minus 2, which is equal to B by minus B by. Always put minus in front of the second variable. Now remove the second column, then find the remaining determinant. So A into 1 is 1 into 1 is 1, 1 minus, then 2 to are 4 minus 4, so plus 4, which is equal to C by. Now remove the third column, then it is minus 1. So if you divide by minus, then x3 will be 251. Therefore the eigenvectors are, therefore the eigenvectors x1 equal to, what is x1? x1 is 2 minus 1 1, 2 minus 1 1, x2 equal to, what is x2? x2 is 1 0 minus 2, 1 0 minus 2, and x3 is what? x3 equal to 2 5 1, corresponding to the eigenvalues 8, 2 and 2 respectively. If the eigenvalues are distinct, then you no need to check this property x2 transpose x3 equal to 0. You have to, if the eigenvalues are distinct, you have to find the eigenvectors as usual. Now normalize the matrix. Normalize these vectors. So if x equal to ABC, then the normalized vector is denoted by x cap, which is equal to a by root of a square plus b square plus c square, and b by root of a square plus b square plus c square, and c by root of a square plus b square plus c square. This is the procedure to normalize the matrix vector. Now find the normalized eigenvectors. The normalized eigenvectors are x1 cap. x1 cap equal to 2 by root of 2 square plus minus 1 whole square plus 1 square. So then what you may get? 6. 2 by root 6 minus 1 by root 6 and 1 by root 6. Similarly, find x2 cap. x2 cap equal to 1 by 5 root 5, 0 minus 2 by root 5. Similarly, find x3 cap. So which is 2 by root of 2 square plus 5 square plus 1 square, 25, 26, 30. So 2 by root 30, 5 by root 30 and 1 by root 30. Now write this normalized matrix, normalized vectors as a matrix that is called normalized model matrix. The normalized model matrix is n equal to 2 by root 6 minus 1 by root 6, 1 by root 6, and then 1 by root 5, 0 minus 2 by root 5, and then 2 by root 30, 5 by root 30, and 1 by root 30. Now find n transpose an. N transpose an. A is the given matrix. N is this normalized model matrix. This orthogonal matrix. If you want, you can check this is a orthogonal matrix. So if you find this one, n transpose an, then you get diagonal matrix like 8 0 0 0 2 0 0 0 2, which is a diagonal matrix whose diagonal entries are nothing but the eigenvalues of A. This is the procedure to find the diagonal matrix of the given matrix. Thank you.